Let's keep on moving through chapter 8. This is 8.2, solving inequalities using addition or subtraction. As you can see in the next section, we'll get into using multiplication or division. And then in 8.4, we'll combine everything we're going to do in these two sections together to solve multi-step inequalities. And again, I plan on skipping through 8.5 at this point. All right, so let's get to it. Solving using addition or subtraction. So here, addition property of inequality. We went through the addition property of equality to start the semester, but the addition property of inequality is essentially the same thing, but now you're dealing with inequalities instead of equations. So if you add the same number to each side of the inequality remains true. So if we do this example here, well, notice it's x minus 6 is greater than or equal to negative 10. So to undo this subtraction, we use the inverse operation, which is addition. So we're going to add 6 to both sides of this inequality, and it should remain true based on that addition property of inequality. So we get x by itself is greater than or equal to negative 10 plus 6 is negative 4, and there's my solution. To graph this, we're going to put that boundary point right in the middle at negative 4. I should get closer to 0 as I go to the right. My negatives my value should be getting larger left to right, and as I get closer to 0 with the negatives, they get larger. So over here I need negative 5. The boundary point should be a closed boundary point because there is an equal to on my inequality symbol right here. And then the greater than symbol means that I need to shade to the right. We need the values that are greater than negative 4, and those are to the right. So that's it. Example number 2 will be coming up in a second, right after we talk about the subtraction property of inequality. Very similar to the addition property of inequality, it says if you subtract the same number to each side of the inequality remains true. So we can either add or subtract the same value to each side of the inequality and it will remain true. So on this one, we have x plus 1.4 on the right hand side here. We need to subtract off that 1.4 from both sides to get x by itself. That will cancel out the positive 1.4 on the right. Negative 8 minus 1.4 is negative 9.4. We have a less than x on the right-hand side here. Now the conventional way of writing inequalities is to put the variable on the left-hand side. So we are going to move the variable on the left-hand side. The variable should go on the left-hand side. I'll just put on the left. All right, so if we're going to do that, if we're going to put x on the left-hand side, you still have to have the inequality mean the same thing. So just look at your inequality symbol here. It's opening towards the x. It's saying that the x is the bigger value. So down here, I'm going to flip everything around. The inequality should still open towards the x. And then I'd write my negative 9.4. So that's how I should be writing my answer, with the variable on the left-hand side. So as I go to make this number line, it is a decimal, negative 9.4. I'm going to put that right in the middle. This is a negative, so I have to get closer to 0 as I go to the right. I'm just going to go up by 1 here, so go to negative 8.4, and then 1 unit farther from 0 on the left, negative 10.4. Since there's not an equal to when I put my boundary, it needs to be an open point, because there is no equal to. We need the numbers that are greater than negative 9.4, and those are to the right, so we are going to shade to the right-hand side of this boundary. Going on to example number 3, very similar, but now we have some fractions. So I need to get k by itself. The inverse operation of addition is subtraction. We're going to subtract 5/6 from both sides of this inequality. K is by itself. We have k is less than 2/3 minus 5/6. Now, in order to add or subtract fractions, we need those common denominators. So how do we make a common denominator? Well, I just need to multiply by a certain kind of 1. I'm going to make it a fraction. Anything over itself equals 1, and multiplying by 1 does not change the value. It might just change how it looks. So I need to turn this denominator into a 6. 3 times 2 is 6. So I'm just going to multiply 2/3 by 2/2, which ultimately equals 1. So it's okay to multiply by. So I get k is less than, multiply these straight across, 4, 2 times 2 is 4, divided by 3 times 2 is 6, 4/6 minus 5/6. Now they're in terms of 6. Now they have those common denominators. We just do 4 minus 5, which is negative 1/6. So that is my solution. It says solve and again graph. So I need to graph this solution. So I'm going to put my boundary right in the middle at negative 1/6. I need to get closer to 0 as I go to the right and farther from 0 as I go to the left. So maybe I'll go up by a sixth and get to 0, and down by a sixth and get to negative 2/6. You could simplify that and put negative 1/3 if you like. So at the boundary here, I'm going to put my open point. There's no equal to, so I don't shade that in because negative 1/6 is not less than itself, so it's not a solution. I put an open point. And then I need all the numbers less than negative 1/6, which are to the left of negative 1/6, so that's how my graph should look. All right, so we just have another 2 examples to go, and then we'll be done with this lesson. So example number 4, it says the maximum volume of this great white pelican's bill is about 700 cubic inches. So the maximum volume. So we can hold 700 or less in that bill. 700 cubic inches or less. It says the pelican scoops up about, exactly 100 cubic inches of water. So it's scooping up 100 cubic inches. Then I need to write and solve an inequality for the additional volume its bill can contain. So it's scooped up 100. It has 100. That's the given amount. We can add some amount more. And it says, again, the maximum volume is 700. So I can't go beyond 700. So I could say the amount that I can fit in there is less than or equal to 700. So write the inequality, done. Solve the inequality. All right, subtract 100 from both sides. And I get x by itself. X is less than or equal to 600. Right, and solve an inequality that represents the additional volume the bill can contain. So yeah, right there, the amount you could fit in that bill is less than or equal to 600 cubic inches. So because this is a word problem, I should answer this with a sentence. I am going to say the additional volume of water that could fit in its bill is less than or equal to 600 cubic inches. And the last example to get through here, example number 5, it says write and solve an inequality that represents the perimeter of the given figure. Here's the given figure, and it says assume all units are in feet, so all these are in feet, and the perimeter, it says, is less than 24 feet. All right, so how you find a perimeter, it's the sum of all of the side lengths. If you add up all the side lengths, and it says if we add all these up, it's less than 24 feet. So if I were to add all these up, so let's show adding all of these together. 1, 3, 2, 4, 7, 5, 4, 7, 5. Doesn't matter what order I add them in. When I add them, I'll get the same result. And then I also have an x. And that's the perimeter when you add all of them up. And it says the perimeter is less than 24, so it's less than 24. So let's combine all these like terms together. So all of the numbers, I've got 1 plus 3 plus 2 plus 4 plus 7. Oop. Plus 5. So that's 22 plus x is less than 24. Subtract 22 from both sides of the inequality. So the subtraction property of inequality. So I have x by itself. X is less than 24 minus 22 is 2. And again, we're assuming these are all in feet. There is my solution as an inequality, but I'm going to go ahead and write down that in order for the perimeter to be less than 24 feet, x must be less than 2 feet in length. There we go. All right, so your assignment is a book assignment, pages 322 through 323, 6 through 18 evens. 25, you only have to do part A, so if there's a part B or C, ignore those. Only part A. And then 28 through 32. So let's take a look at some of those. So on 6 through 18 here, it says solve the inequality and graph the solution. 6 through, 18 is describe and correct the error. So 6 through 16, because you only have to do the evens, solve the inequality, graph the solution. So on every single one of these, it's going to require either the addition property of inequality or the subtraction property of inequality. So like on number 6, you just add 3 to both sides of the inequality, you get y is greater than or equal to 10, and then you'd have to graph that solution on a number line. So you're going to do that on all of these. Now, I know some of you do not like fractions one bit, so I will go through a couple of these with the fractions, and then you will have to do the rest of them. So let me find an even one here with some fractions in it. 10 is not so bad. You add 1/2, you get 5.5. How about 12? 12 is probably going to be the worst one out of the evens. So number 12. We'll do that one together. We have negative 2/3 is less than or equal to g minus 1/3. Well, this one's not too bad because they already have common denominators. So I add 1/3 to both sides of the inequality. That gets rid of that one. G is all by itself. Negative 2/3 plus 1/3 is negative 2 plus 1 is negative 1/3. Again, you want to put the variable on the left-hand side. So g is, this opens towards g. So the symbol should still open towards g, and then I write my negative 1/3. So g is greater than or equal to negative 1/3 is the solution. And you do have to graph that on a number line. I should make a better number line. So negative 1/3, my boundary is in the middle. Then I go to negative, I'll go by thirds, negative 2/3, or if I go up 1/3, I get to 0. Put my boundary point in the middle. Because there's an equal to, I need to shade it in, which shows that that is a solution. And then it says greater than negative 1/3, so I need to go to the right for all those numbers that are greater than negative 1/3. So that's the answer to number 12. You'll have to do the other evens there. Number 18, describe and correct the error in graphing the solution to this. If you add 5 to this side, you get a 10. But notice, here, let me write on this one. If I were to write this with the variable on the left-hand side, so if x was on the left, the symbol opens away from x, and then I have my 10. It says x is less than or equal to 10. So actually, I should be shading to the left of 10 because that is where you find those values that are less than 10. They shaded to the right, and that is incorrect. The boundary should be filled in as they had it, so that was okay. So the only error is that they did not shade on the correct side of their number line, and that happened because they did not put the variable on the left-hand side, and this confused them. So on number 18, describe the error. I would say they shaded on the wrong side of the number line. So I would write that down. They shaded on the wrong side of the number line. And then correct the error. You would just redraw the graph with the correct shading. All right, let's go to 25 just to talk about it a little bit here. 25, this is 25, and you only have to do part A. You do not have to do part B. And notice this diagram here, you will have to use the current score of 4,500 in this problem. So it says you need at least means greater than or equal to. Remember, you must be at least this tall to ride this ride, greater than or equal to. At least 12,000 points to advance to the next level. Write and solve an inequality that represents the number of points you need to advance. So I'm going to say, okay, I've got X points. Oh, I'm sorry, it says current score of 4,500. So I've got 4,500 points already. I need to add, or I'm going to add X points more, and then you need at least 12,000. So that would be the inequality. That right there is the answer to part A. And you don't have to do part B. So I just gave it to you. All right, 28 through 32, these are just review problems. So it says solve the equation. Solving equations, this is something you've done, yeah, way back in section 1.1. Chapter 1, section 1, this was like day 1 or 2 material for pre-algebra. So I'm not going to give you any of these. I'm going to give you a small hint on 31. Remember multiplying by the reciprocal to help get rid of that fraction. And then the rest of these, I think you can handle. If not, please feel free to send me an email. Okay? Have a great day.